Hi, it's Bates here, and today I thought I would explain the cryptographic process of CommitReveal. It's a technique that's used in, for example, strategies for overcoming front running, in the generation of random numbers on the Beacon chain in Ethereum, and a whole bunch of other areas. And it's actually quite simple, but I've not seen a good explanation anywhere. And the funny thing is, if as a kid you played rock, paper, scissors, then you kind of already engaged in a commit reveal sequence. When you're playing it, remember, you go 1, 2, 3, scissors in that case. So that 1, 2, 3 phase is kind of a commit phase, and then when you show the scissors or the rock or the paper, then you're doing a reveal. Now, it's not a very good commit reveal approach, because of course I can go 1, 2, 3 and think along the time that I'm going to reveal scissors, and then in the last minute I can change my mind and say paper. So what you want is a commit that doesn't show the solution, but that does commit you to, when you show the solution, actually having made up your mind beforehand. So it's a bit more like this: 1, 2, 3, rock. There we go. So by putting the rock in my fist, I've committed to rock. I can't change that once I'm going 1, 2, 3, and then when I'm revealing it, everybody else can see that I did indeed select rock. And if we had a little token for scissors and for paper as well, we could all commit to our rock or paper or scissor choice before showing it to everybody else. And in cryptography and in blockchain, the way that you do a commit and then a reveal is that you commit by publishing a hash of your choice, and then in the next step you publish the actual choice, and then everybody can check that your choice hashes to the hash that you previously committed. And for example, I said it's used in front-running overcoming strategies. So if you want to have a system where people submit transactions but you want to avoid other people copying them, you can require that transactions are provided in 2 steps. The first one is that in one block you publish a hash of the transaction that you're going to use, and then in the next block you publish the actual transaction. And you have the system set up so that transactions are only acted on if there's a commit to the transaction in a previous block. And that stops front running, because people can see that you've committed to a transaction. In the next block they see what your transaction is, but they can't copy it and submit it with more gas to front run you, because they haven't got their own commit in the previous block. And they can't just copy your hash, because each transaction will have a different sender, and therefore it will hash to a different value. So it's a neat technique. I mentioned that it's also used in the Beacon chain, and there again you're trying to get a group of people to each select random numbers. And what you don't want is for somebody to see what the other random numbers that people have selected are, and then specifically craft a non-random number that, when all those random numbers are scooped up together, plus this malicious non-random number, it gives the outcome that the attacker desires. So everybody has to commit to their random number before they show it, and that means that people can't influence other people's choices. And there are heaps of other examples of commit reveal that use this very property. Anyway, that's today's video. I hope the illustration of rock, paper, scissors explained to you how it works. If you're working in Solidity or smart contracts, it's a technique that you may well find solves some of the problems you have in trying to overcome malicious attackers subverting your system. That's it for today. See you in the next video soon. Bye for now.